I welcome you to the channel which explores intellectual content for the benefit of faculty, students, and industry professionals. This video exchanges the views on when a researcher should use experimental approach, typically conducts the experimentation for various engineering management problems. I am Professor Jitesh J. Thakkar, Dean Academics and Professor Logistics and Supply Chain Management at Gati Shakti Vishwavidyalaya, GSV, India's first university in transportation and logistics sector. The university is a central university established by Ministry of Railways, Government of India. I am ex-professor IIT Kharagpur and contributed in the domain of transportation, logistics, and supply chain. Let me introduce you to the channel. The name of the channel is Professor Dr. Jitesh J. Thakkar. Currently, this channel has two playlists. One is the faculty and student development, and the other is logistics, supply chain, and infrastructure projects. You can scan this QR code on the right hand side and explore the intellectual content on this channel, benefiting students, industry professionals, and faculty. About this playlist, faculty and student development. Faculty and student development is a multifaceted agenda which requires grooming on three important dimensions. Number one, teaching. Number two, research. And number three, experiential learning. The aim of this platform is to address how faculty and student can respond to evolving landscape demanding interdisciplinary teaching and research as expected by new education policy NEP 2020, and this platform shares the content broadly in three important domains. So first is enhancing teaching learning using improved pedagogical skills, motivating, innovating the teaching pedagogies and classroom engagement techniques, student engagement strategies, utilizing educational technology, foster critical thinking for solving complex problems. Number two, promote research excellence and productivity by providing training in research methodologies, data analysis, and scholarly writing. And number three, enhance experiential learning through projects, internships, and exposure to real-world problems. This platform explores the various critical dimensions pertaining to faculty and student development for enhancing the capability and quality of the most important stakeholder in higher education system in India, that is faculty and students. Let me introduce my university, Gati Shakti Vishwavidyalaya, GSV. Gati Shakti Vishwavidyalaya Central University was created in 2022 by the Act of Parliament. GSV is established by Ministry of Railways, Government of India. It has a unique mandate to create a best-in-class resource pool for the entire transportation and logistics sector, including rail, road, water, aviation, and shipping across all three dimensions: technology, that is infrastructure; management, that is services; and number three, that is policy, reforms and regulations. It offers undergraduate program, postgraduate program, PhD, and executive training for creating the best-in-class human resource for transportation and logistics sector. It follows a demand-driven curriculum to meet industry needs of the transportation sector, high-quality faculty with global exposure, leveraging state-of-the-art infrastructure of centralized training institutions of Indian Railway, sets a perfect pitch for Gati Shakti Vishwavidyalaya to meet the aspirations of developing challenges in the 21st century and aspirations of the nation to become developed nation by 2047. GSV is propelling the nation towards an era of interconnectedness and sustainable development through innovations and best practices in transportation and logistics sector. The vision of the university is innovation-led and industry-driven to meet the challenges of 21st century and aspirations of the nation. The mission of the university includes best in the world futuristic education and research, effective collaboration with industry and stakeholders, and imbibe and internalize professional work ethics and culture to foster lifelong learning paradigm for a developed India. The academic programs at university includes the programs for regular students, BTech in civil engineering with specialization in railway engineering, BTech in electronics and communication engineering with specialization in railway engineering. Similarly, BTech in mechanical engineering with specialization in rail engineering, BTech in electrical engineering, BTech in artificial intelligence and data science with specialization in transportation and logistics, BTech in aviation engineering, MBA in logistics and supply chain management, MBA in ports and shipping logistics, jointly offered with Indian Maritime University. You can see that there is a complete portfolio of the academic programs for the regular students, which cuts across the different dimensions of transportation and logistics with a vision to create best-in-class resource pool for the sector of logistics and transportation in India. On the other hand, we have the program for working professionals, which are offered in a hybrid mode, in which 80% of the content is covered through online real-time sessions, and for 20% learning, they need to come to the university for campus immersion. So the programs like MTech Intelligent Transport System, MTech Railway Engineering, MTech Bridge and Tunnel Engineering, MTech Roads and Highway Engineering, MBA Logistics and Supply Chain Management, MBA Metro Rail Management, MBA Multimodal Transportation, MBA Aviation and Operations Management, and PhD in Engineering and Management with a special focus on transportation and logistics sector are offered for the working professionals. This video exchanges the views on when a researcher should use experimental approach. So typically we call it as a design of experiment or experimentation approach, which is quite a robust and a classical approach to derive the inferences for a complex system using the real-time data and statistical analysis to infer the necessary insights for the given engineering management context. My experience in experimental research, I taught a course on design of experiment to undergraduate, postgraduate, and PhD students during 2013 to 2018 at IIT Kharagpur, published research using experimental research approach. You may like to refer to my contribution in experimental research. It is the paper published in International Journal of Production Economics, volume 217, November 2019, Modeling and Analysis of Intermodal Food Grain Transportation under Hub Disruption Towards Sustainability. And typically this paper utilizes the optimization approach along with the experimental research design. It is published by Loitaksha M. Mayar, who is a faculty at IIT Hyderabad, and myself, Jitesh J. Thakkar. A researcher broadly should consider using an experimental approach when they want to establish a cause and effect relationship between variables. The approach is characterized by manipulation and control, allowing researcher to determine if changes in one variable directly cause changes in the another. You have set of independent variables to maneuver with, and you would like to investigate the impact on the dependent variable. For example, your dependent variable is productivity, and you have worker employee, morals, skills, technology, all these are independent variables. You may like to see the impact of these independent variables on the dependent variable, that is productivity. Let us look at some of the interesting situations for using the experimental research approach, and this will bring better clarity on when to really look for the experimental or design of experiment approach to conduct our research in a more rigorous and relevant manner. Number one, establishing cause and effect. When typically you are interested, your goal is to determine the cause and effect relationship between independent variable, that is the cause, and dependent variable, that is the effect. You would certainly like to opt for the experimental approach. So, controlling extraneous variables, researcher many a times aim to control for any other factor that could influence the dependent variable. These are the extraneous variables, not desirable, because that will marginalize your investigation on judging the impact of independent variables on the dependent variable, and you want to observe the effect to the manipulation of the independent variable. We can look at the example. A researcher wants to determine if a new fertilizer independent variable causes an increase in crop yield, that is the dependent variable, and they would control factors like sunlight, water, and soil quality to isolate the effect of the fertilizer. The second situation or the motivation or the goal where we would like to opt for the experimental research approach is testing hypothesis. So you have a specific prediction, assumption, hypothesis about the relationship between variables, and the objective of testing is to investigate a way to objectively test the relationship or the hypothesis through data collection and analysis. For example, a researcher hypothesizes that listening to a classical music improves cognitive performance, and they would design an experiment to test this hypothesis by comparing the performance of participants who listen to classical music with those who don't, and you would like to compare these two groups. Number three, when manipulation of variables is possible and also it is ethical. So, controllable variables, the researcher can manipulate the independent variables in a controlled manner, and typically the ethical considerations, manipulation does not pose any ethical concerns or risk to the participants. Typically in medical science or healthcare domain, in many situations, it's not possible for you to manipulate with some of the variables pertaining to patient health or their body, and you cannot meet the ethical consideration, and experimental research cannot be conducted. So example is testing the effectiveness of a new teaching method in a classroom setting where the teacher can implement the new method in one group and compare their performance to a group using the traditional method, and you are interested to see whether the new method is impactful or not. When the fourth situation in which we would like to utilize the experimental research approach is when precision and control are of utmost importance. So researcher wants to minimize bias and ensure that the results are due to the manipulation of the independent variable, not absolutely because of any other factor. So replicability, the experimentation is designed to be replicable by other researchers, means after some time even the other researcher would conduct the experiment using the same conditions, they should be able to replicate the results, ensuring the reliability of the findings. Example could be conducting a laboratory experiment to test the effects of a new drug where conditions can precisely controlled and measurements can be highly accurate. So if you look at the key features of experimental research approach, then number one, manipulation. The researcher manipulates the independent variables to create different conditions or groups and see its impact on the dependent variable. Number two, control. The researcher controls for extraneous variables to isolate the effect of independent variable, and hence a more accurate and reliable study can be conducted which judges the impact of independent variable on the dependent variable. Number three, randomization. Participants are often randomly assigned to different groups to ensure that groups are comparable at start of the experiment and absolutely there is no bias involved. Number four, comparison. The outcomes of different groups are compared to determine the effect of the independent variables. Let us look at the types of experimental designs, broadly how it is classified and what to use when. So broadly, experimental research design are classified into four categories. Number one, pre-experimental, which is further classified into one-shot case study, one group pre-test, post-test, and static group. Number two, true experimental, which is further classified pre-test, post-test control group, post-test only control group, and Solomon 4 group. Number three, quasi-experimental, time series, multiple time series, and number four, which is widely used, is statistical experimental research design. This involves randomized block design, Latin square design, and the most widely used factorial designs. Let us try to briefly understand the four broader domains of the research design and the kind of situation where we can use them. So let us see the first category, that is pre-experimental research design. So these are the weakest experimental designs, offering little to no control over extraneous variables. It means your independent variables are not isolated. They will have influence of the extraneous variables. They lack randomization and often a control group, making it difficult to establish cause and effect relationship. And primarily, this is used for exploratory research rather than identifying the causality with the statistical significance among the variables. So the types could be within this category: one-shot case study. A single group is exposed to a treatment and then observed. Number two, one group post-test, pre-test, post-test design. A single group is measured before and after a treatment. And number three, static group comparison. So two groups are compared, one that received a treatment and one that did not, but no randomization is used. So we can look at the examples in engineering domain as well as in management domain. For example, a company installs a new type of LED lighting in a factory. It is a one-shot case study and then measures the reported worker satisfaction. If worker satisfaction is high, they assume the lights are the cause without considering other factors. Similarly, a civil engineer tests the strength of one type of concrete. Before and after a new additive is put into the mix, there is no control group exists. Management, we can apply this pre-experimental designs. For example, a manager implements a new sales training program, one group pre-test, post-test, and then observes if sales increases. Any increase is attributed to this intervention that is called training, ignoring other potential influences. Similarly, a company introduces a new workflow to one department and then compares the productivity of that department to the another department and try to see the impact of this intervention, typically the workflow management. The second one is your true experimental design. This design provides the highest level of control, allowing for strong causal inferences. They involve random assignment of participants to treatment and control groups, and they include a control group. So here we are trying to overcome all the shortcomings of the previous design. Types could be randomized control group, pre-test, post-test design, randomized control group, post-test only design, and third is Solomon four-group design, combines pre-test, post-test, and post-test only designs. We can look at the examples to make the idea clear. For example, in engineering, testing the effectiveness of two different corrosion resistance coating. Still, samples are randomly assigned to two groups, one with coating A and the other with coating B or a control. Corrosion levels are measured after a set period, testing the efficiency of two engine designs by randomly assigning engines to vehicle and measuring fuel consumption. Similarly, we can look into the examples into management domain. Evaluating the impact of a new performance appraisal system, employees are randomly assigned to either use the new system or the old system, and their performance is then measured. Similarly, I may be interested to test two different advertisement campaigns by randomly assigning the customers to see one of the two ads, then measuring the sales. The third experimental design approach is quasi-experimental design. Typically, these designs fall between pre-experimental and true experimental design. They lack full control, typically due to the absence of the random assignment, and researchers attempt to control for confounding variables through statistical techniques. So, there are three different types within quasi-experimental design. One is non-equivalent control group design, where I'm interested to compare two existing groups that differ in treatment but no random assignment. Interrupted time series design, measure a single group repeatedly before and after a treatment. And regression discontinuity design, participants are assigned to groups based on a cutoff score. We can look at the engineering example to appreciate quasi-experimental design. I may be interested to compare two safety records of two factories, one that implemented a new safety protocol and one that did not. Factories cannot be randomly assigned. Measuring the air quality in a city before and after a new emission regulation is implemented, and the examples in management may be like evaluating the impact of a new software system on productivity in two departments, one that choose to adapt it early and the another second one that adapts it later. The another example is analyzing the impact of a new government policy on small business growth by comparing businesses above and below a specific revenue threshold. The fourth experimental research design is statistical design, factorial, etc. It is the widely used experimental approach, and this design focuses on statistical analysis of multiple independent variables or factors and the interactions among them. They allow for efficient exploration of complex relationships. The types could be factorial design, examines the effect of two or more factors. Response surface method optimizes a response variable by varying the multiple factors. And third, analysis of variance, where I may like to investigate the comparison among different group means or the standard deviations using the statistical technique. We can look at a couple of examples in the engineering domain where statistical experimental designs are widely used. Let us say I'm interested to test the effect of both temperature and pressure on the yield of a chemical process using a factorial design. Similarly, optimizing the strength of a composite material by varying the proportions of different components using response surface methodology. Couple of examples in management could be analyzing the effect of both training and incentives on employee performance using a factorial design. Optimizing marketing campaigns spending across multiple channels to maximize return on investment. Let's try to make our discussion a bit more interesting and see, are you really in a position to identify the appropriate or the best fit experimental research design? So, which experimental design do you select for the given situation? Let's say the engineering situation is like this: testing the strength of 4 different types of welding techniques. Steel samples are randomly assigned to each welding technique and the tensile strength of each welding sample is measured. Similarly, I have the management situation evaluating the effectiveness of 3 different training programs for customer service representatives. Employees are randomly assigned to one of the 3 programs and their customer satisfaction scores are measured. So for this kind of situation, which experimental design would be the best fit or most appropriate? So the answer is completely randomized design can serve the purpose, the best fit design, because it is simplest design. Experimental units are randomly assigned to the treatments and suitable when units are homogeneous, which is the case here. Let us look at the another situation. So, which experimental design would you select? Let us say for the engineering situation, investigating the impact of temperature and pressure on the yield of a chemical reaction. A factorial experiment would test all combinations of different temperature and pressure levels. Management situation, analyzing the effect of both employee incentives and team size on project completion time. Factorial design can test all combinations of different incentive levels and the team size. So already I answered that factorial design because it examines the effect of 2 or more variables, independent variables, factors, and their interactions, which is really of interest and allows researchers to understand how factors combine to influence the response variables. The another situation could be engineering situation measuring the corrosion rate of a metal alloy over time when exposed to different corrosive environments. The same metal samples are repeatedly measured at different time intervals. Management situation could be evaluating the impact of different software interfaces on the user performance. The same users are asked to perform tasks using each interface and their completion times and error rates are recorded. So, which experimental design would you select? The answer is repeated measure design, because the same experimental unit is measured multiple times under different treatments and it is useful for studying changes over time or the effects of treatment within individuals. The another example to bring better clarity, which experimental design would you select? Let us say we have the engineering situation comparing the accident rates at intersection before and after installation of a new traffic signals. Due to practical considerations, researchers cannot randomly assign interactions to receive the signals. So randomization is not possible. Management situation, assessing the impact of a new company policy on employee morale by comparing the morale of employees in departments that implemented the policy early versus those that implemented it later. The random assignment of department is typically not possible. So, which experimental research design would be the best fit? And the answer is the best fit is quasi experimental design. Lacks random assignments of participant to groups used when true randomization is not feasible or ethical, and researchers attempts to control for confounding variables using statistical techniques. So broadly, if we see, there are key considerations in experimental designs. Number one, control group, essential for comparison in many designs. Replication, repeating the experiment to increase the reliability. Number three, randomization, which minimizes the bias. Number four, confounding variables, factors that influence the response variable other than the treatments. So, in summary, we can say that experimental research is characterized by manipulation of one or more variables, typically independent variables, to observe their impact on another variable, that is dependent variable, while controlling for various extraneous factors. Let us look at some more examples, applications of experimental research in engineering, management, healthcare, and so on. So typically, let us say civil engineering, I want to do material testing. So testing the compressive strength of different concrete mixtures under varying environmental conditions, temperature, humidity, sets the case for using the experimental research design. Evaluating the tensile strength and fatigue life of steel beams with different welding techniques. Investigating the performance of new asphalt mixtures in response to different traffic loads and weather patterns. I may be interested to do structural analysis, conducting load tests on bridge models to assess their structural integrity. Analyzing the seismic response of building models to simulated earthquakes. Here also I can use the experimental research design. Similarly, studying the effect of wind loads on the building using wind tunnel experiments. So I have conducted the experiment and then I can analyze my results using these statistical techniques. Geotechnical engineering, performing soil compaction tests to determine the optimal compaction methods for foundations, analyzing the stability of slopes under different groundwater conditions, and investigating the effectiveness of different soil reinforcement techniques. If we look at the mechanical engineering, then fluid dynamics, conducting wind tunnel tests to optimize the aerodynamic design of cars and airplanes, analyzing the flow patterns of fluids in pipes and pumps, investigating the heat transfer characteristic of heat exchangers. Material science is another domain where experimental research designs are widely used, testing the wear resistance of different coating on machine components, evaluating the mechanical properties of new composite materials, and so on. Thermodynamics, I may be interested to measure the efficiency of internal combustion engines under different operating conditions. I may be interested to analyze the performance of refrigeration and air conditioning systems and investigating the effectiveness of solar thermal collectors that sets the perfect pitch for using the experimental research design. Chemical engineering, I want to undertake some study in reaction engineering, optimizing the operating conditions of chemical reactors to maximize the product yield, investigating the kinetics of chemical reactions, similarly separation process and material processing are some of the examples where the experimental research design can be effectively deployed. Electrical engineering, I want to design the circuit So testing the performance of new electronic circuits under different operating conditions, analyzing the electromagnetic interference, EMI of electronic devices, investigating the characteristics of semiconductor devices, similarly power systems, testing the stability of power grids under fault conditions, investigating the efficiency of power electronic converters, and similarly, you can deploy the experimental research design for the domain of communication, evaluating the performance of wireless communication systems in different environments. Researchers carefully design and conduct experiments to gather data, analyze results, and draw conclusions that advance your understanding of engineering principles and improve technological capabilities. So this is the core strength of experimental research design. Typically, when it is deployed to the engineering domain, let us look at more applications of experimental research in transportation, logistics, supply chain management, SCM, healthcare, and marketing. So let us see, transportation is one of the very interesting and critical area where experimental research design for different kind of problems can really benefit the researcher. For example, materials and infrastructure, pavement testing. So testing the durability of new asphalt or concrete mixture under simulated traffic loads and environmental conditions. This can involve using machines to replicate the stress and strain of vehicles, and you can conduct the experimental research design. Similarly, bridge engineering, conducting load tests on bridge models or real bridge sections to assess their structural integrity and identify potential weaknesses. I may be interested to analyze the effects of vibrations and wind loads on bridge structures using wind tunnels and simulation softwares. You can look at the railroad engineering, testing the fatigue life of railroad tracks and wheels under simulated heavy loads. I may be interested to evaluate the effectiveness of the different track maintenance techniques to reduce wear and tear, or analyzing the dynamics of train track interaction to improve safety and reduce noise. There are a lot of applications of experimental research design even in the traffic flow and safety. So driving simulator studies is one of the area where I'm using the driving simulators to study driver behavior under various conditions, and such as say driver behavior, driving behavior, or distracted driving, impaired driving, or adverse weather. Similarly, investigating the impact of autonomous vehicles on traffic flow and safety. The other domain in transportation, traffic flow and safety, is road safety and experiments. I may be interested to analyze the effectiveness of different road safety measures such as roundabouts, speed bumps, or warning signs in reducing accidents. Behavioral studies, conducting studies on how people react to different forms of transit information, testing how different pricing models affect people use of public transit. We can look at even the domain of logistics and transportation broadly. I can conduct the experimentation for supply chain, simulating different supply chain scenarios to optimize logistics and reduce transportation costs, evaluating the effectiveness of new technologies such as drones or autonomous trucks in improving delivery efficiency, public transport studies, analyzing the ridership patterns of public transportation systems to optimize routes and schedules, evaluating the effectiveness of different public transportation technologies such as electric buses or light rail systems, and so on. There are very good applications, impactful areas where experimental research has proven a great utility in logistics and supply chain management. One of these areas is inventory management. I may be interested to test different inventory control policies, maybe just-in-time inventory versus traditional stock keeping, different reorder point and reorder quantity, And this is something where I can deploy an appropriate experimental research design to investigate my issue thoroughly and rigorously. Analyzing the impact of demand forecasting accuracy and different models, experimental research can be conducted. Transportation and distribution is another area within the logistics and supply chain. So, optimizing delivery routes, evaluating the effectiveness of different transport modes, and testing the impact of last mile delivery options are some of the examples where I can deploy an appropriate experimental research design to direct my investigation and inquiry in a more rigorous and fruitful manner. Warehouse operations. I may be interested to analyze the impact of warehouse layout on efficiency, evaluating the effectiveness of warehouse automation technologies like robots, AGVs, automated guided vehicles, robot picking system, warehouse efficiency, and so on. And maybe I would like to investigate the impact on the factors like throughput, labor cost, error rates. Similarly, I can analyze the supply chain collaborations and contracts using the experimental research method clubbed with the simulation methodology. We can also deploy experimental research method, maybe clubbed with the simulation method in medicines and healthcare. So clinical trial for new drugs, I want to see the impact and efficacy of the new drug and compare their health outcomes. Effect of exercise on the blood pressure. Similarly, impact of a new surgical technique on the recovery time of a patient. Marketing and business is another domain where I can successfully use experimental research method, for example, effectiveness of different advertising strategies. Researchers test different advertising campaigns, different and copy different media channels and measure their impact on sales or brand awareness. Similarly, impact of pricing strategies on consumer behavior, influence of store layout on consumer spending, and so on. So, if we just summarize, then the key elements involved in experimental research are manipulation. Researchers actively change the independent variable to see their impact on the dependent variable. Number two is the control. Researcher attempts to control for extraneous variables which should not become part of my study when I am investigating the impact of independent variable or on the dependent variable, or I am trying to investigate some trial or intervention which is under consideration. Number three, random assignments. So randomly, I would like to assign the participants or the entities to different groups to ensure the comparability. Number four, measurement. Researcher measures the dependent variable to observe the effect of manipulation. And fifth is the comparison. The outcomes of different groups or conditions are compared. So this video has provided you a comprehensive and critical understanding on the use of experimental research method with numerous applications in engineering, management, logistics and supply chain management, transportation, warehousing, and various other domains. I hope this knowledge will help you to choose the right research method for directing your investigation in the desired direction in line with your research questions and research objectives. About Gati Shakti Vishwavidyalaya, it is India's first and only university in transportation and logistics sector, has a unique role to play in terms of creating highly skilled manpower for all the modes of transport, rail, road, aviation, water, ports, and shipping. GSV extends programs at all levels, undergraduate, postgraduate, PhD, and executive training to enable nation's aspiration to reduce its logistics cost from present 14% to 8 to 9%. transportation sector is a growth engine for India, which contributes roughly 6.3% of GDP of India. University offers demand-driven curriculum with a focus on all three dimensions: technology, that is infrastructure; management, that is services; and policy, that is regulation, to strengthen the ecosystem of multimodal transportation and logistics in the country. In line with the vision, innovation-led, industry-driven university, Gati Shakti Vishwavidyalaya has collaborated with the various prestigious leading industries such as Airbus, Nippon Koi, Jacobs, Siemens, Nokia, Plaza India, Railtel, and many others to significantly contribute to the ecosystem of transportation and logistics sector in India and across the globe. Thank you for your interest in learning the various dimensions of faculty and student development. We will keep exploring more issues through this platform for the benefit of faculty and students, most critical entity in the higher education in India. Thank you very much.